Good morning. Thanks for the invitation, the opportunity to be here. So I use this cartoon usually to explain to amateurs why they should listen to public alerts. But let's see why they're. Let's look at it from the pro community perspective as well. So let's briefly define what amateur astronomy is. So for the purpose of my talk, the term amateur just refers to someone who's amateur astronomer who's doing astronomy, so following scientific method, not just doing not just stargazing or doing pretty pictures with their telescopes, and is not paid for it, and isn't paying for it because he or she is in the process of being trained to become a professional astronomer one day. So it doesn't have to do with education, or as we'll see in a minute, it doesn't have to do with this amateur status with equipment. For the purpose of my talk, everybody is of course free to use that term as he or she likes. So let's just briefly step through the messengers and see what amateurs could do theoretically. So as of now, amateurs only have terrestrial observations, which starts that's in itself, it's limiting us, of course. And in the electromagnetic spectrum, we cover wavelengths, well, the classical UV-BRI filters and a bit more. So from 350 nanometers to the point where silicon sensors pass out, so 1,000 nanometers, 1,100 nanometers at best. And there we can do photometry, a little bit of astrometry, limited by the seeing through the atmosphere. But a growing number of amateurs is also doing spectroscopy. I mean, starting from very low spectroscopy, just using slitless spectroscopy, just with screw-in filters that have a grating etched on them, like 100 or 200 lines per millimeter, up to really capable spectrographs that sometimes they 3D print themselves and perfect themselves and whatnot. So what about other messengers? So neutrinos, no. Gravitational waves, no. Gamma rays, X-rays, no. Radio. So there's actually one group in Germany, I guess not so far from here, who are now the caretakers of an ancient 25-meter dish. But otherwise, there's one company in Italy that will sell you for around 50,000 bucks a 3-meter dish with receiver and over 1,000 channels and optimized for 1.4 gigahertz. But I mean, what can you do with a 3-meter dish? So yeah, probably not that useful. There are a few projects about cosmic rays. There's one that tries to use smartphone camera chips as detectors, but I mean, those are so super tiny. You would need a whole army of people to make up for that. There's another project that is perhaps more promising that has reached prototype stage, and they use scintillator sheets with silicon photomultipliers, but they've always been kind of slow, and they've now come to a halt because of supply chain problems, like their scintillator plates they wanted to source from Ukraine, and yeah, that was the plan. So much for the plan. We'll see. Okay, so we are left with optical astronomy, and I mean, if you just look at the economics of building observatories with increasing as a function of aperture size, you will see that how the cost rises with aperture is quite brutal. So for 300 bucks, you will get mostly toy and recreational telescopes. For 3,000 bucks, you can already get decent amateur equipment with like 200 millimeters aperture, and you can do real science with that. You can do photometry, time series photometry, and very low spectroscopy, all at that budget. And actually, the most expensive here are the filters, the photometric filters. Now, if you want to go to something like 40 meters, 40 centimeters, I mean, you're already in this several 10,000 euro regime, and but that's where a lot of ambitious amateurs are building their own observatories with nice enclosures, with huts and whatnot in the countryside, typically after retirement. And there are even some crazy amateurs who invest like the cost of a small house to build their up to, say, 1 meter aperture telescopes. There's one amateur astronomer I know from Belgium who's remotely operating his own observatory in the Atacama Desert in Chile. So that's the whole spectrum, and beyond that, that's really just a professional territory. But here there's certainly some overlap between the equipment that amateurs use and equipment that the pros use, because I mean, even in professional astronomy, there is small aperture science. I mean, if you look at TESS, the satellite, it has just each camera has just 10 centimeter aperture, and it's doing useful science, right? I mean, there's even things like the kilo degree extremely little telescope, CALT, managed by these institutions, and it has 0.042 meter aperture. That's 4 centimeters, and they're doing science with that. And even so, well-known service like Assassin, at least for their first two telescopes, where they still had reputable assassins to name them after, they use actually consumer off-the-shelf Nikon telephoto lenses at 14 centimeters aperture. So what does help a lot recently for amateur astronomy is that CMOS cameras are now really at an affordable price point, are really capable. Not because the industry has now found us as a target market. Those are all designed for surveillance and security cameras, which all need to have low noise, high quantum efficiency. So we are at a 90% level here. They have higher resolution than we would like in the astronomy community, but they have so low readout noise that it doesn't matter. They have acceptable full well capacity. You can read them out at gigabits per second. That's just brilliant. And all that for just 1,500 bucks. So, so we are at a regime where you can throw twice the money at it, and still you can't improve on that too much, because we're actually now bumping against the laws of physics here, and not so much against limitations by the equipment. Okay, another big change that helps us a lot is that thankfully the professional science, I guess in general, community is moving more and more towards open software, open data, and documenting their software really well, so that we're moving away from semi-obscure packages to something that is easily installed. No offense to IRAF, but someone told me when he was a student, they said there was an axis of evil: Iran, Iraq, Iraq. So yeah, and now it's Python and stuff that is open and easy to install, and that helps a lot, and a lot is available online. So let's get a bit concrete and see how this all could play out with a very iconic event. I guess maybe a lot of people in this room are co-authors of this paper because it was such a big event. It's the first multi-messenger observed binary neutron star merger, GW 170817, and all the rest of the telephone numbers for the other counterparts. I guess we all know the timeline still. So it was discovered in gravitational wave data and by a coincident gamma ray burst at this time. And the first, it took a bit to make the first reasonably good sky localization map, and but that happened at 17, or let's say 1800 UTC. And then it took a long time before the actual optical counterpart was found in NGC 4993 in the constellation Hydra. And it was found by many telescopes almost simultaneously, also by a 40-centimeter telescope, which is, I mean, that is clearly also, as we have seen in the amateur regime. I myself in my backyard have a 20-centimeter telescope, and so I would just have to expose like 4 times as long to get a, okay, maybe 10 because I have a worse sky. But why did it take so long? And the reason in this brilliant paper is that, given in that paper, is basically that the object had to rise over Chile, because there all the professional telescopes are. But I mean, if you look up, and of course there were 0 amateur contributions to that, because as most of you will know, the groups that were involved in this all had to sign an NDA up front that they wouldn't tell anyone else about this. So we couldn't know. Would it have helped to have known this? Well, the object was up at still 40 degrees altitude in the sky over western parts of southern Africa. It wasn't that difficult to find. I mean, it was just, the sky region was just 30, 40 square degrees. That's a lot of sky, but we knew that it was close. So you just have to look at the galaxies at that, consistent with that distance. And that would be like also 30, 40 of them. And so it wasn't difficult to find. Yeah, so, but we will never know, because we don't know what the light curve was at that point. And there are a lot of telescopes there in that area, because there's an astro farm industry where people can go to, say, Namibia and make pictures with from the southern night sky, because it's much darker skies there. So there are a lot of telescopes here, but yeah, didn't work out. So how can we do this better in the future? Well, these days, if we stay with gravitational wave triggers, the triggers are now public and can maybe more rapidly skip through this, because we've already seen this in a talk. There's a project called Kilonova Catcher, which is managed by the Grandma project. And if you want to see how a test run was done, you can look at this paper. Some of the authors here are amateur astronomers who contributed data. Of course, amateurs like that if their contribution is credited in this way, and it's fair, I guess. The nice thing about it is that it demonstrated that it's possible to take amateur images, or images contributed by amateurs, and then do the sky subtraction with catalog data from professional professional surveys like Pan-STARRS or whatnot, because that's what you need to do when you see some new transient in a galaxy. If you want to take that light curve, amateurs are quite good at doing aperture photometry, but we haven't yet, most of us haven't yet learned how to do this background, how to subtract the contribution from a host galaxy. So this is done by kilonova catcher on the central server with survey images from professional surveys. But it works, and it's not self-evident that it would work, because most of the time amateurs use different filters, like the Johnson-Cousins photometric system. And yeah, there's another project you might not have heard from. This is REFIT, Recommender Engine for Intelligent Transient Tracking. So it's kind of similar. Amateur astronomers register with detail about their equipment and their observation sites, and then REFIT gets interesting alerts from currently ZTF, and I guess at one point Vera Rubin, and identifies interesting objects, and then based on the observation capabilities of each registered observer, their observation site, location on Earth, and even the weather forecast, and the predicted light curve of the object, it then creates for every observer that is registered a tailored list of recommendations for the next observation night with objects that he or she can observe, given all these constraints. And then observers take pictures. They are allowed to also contribute a measured magnitude, but you can also just upload the calibrated images, and then again, this background subtraction can be done on the server side. So, I mean, it's always like this. I mean, you need to engage with a group of amateur astronomers with, well, hopefully mid-sized to big, in amateur terms, apertures, who then signal their willingness to contribute, and then keep observing and reducing their data. Either they send just images, or they send reduced photometry, spectra, whatnots. Yeah. So, and if this is about very transient kind of objects, then of course here public alerts through GCN or Astro-COLIBRI come in for REFIT. There's such an abundance of things to observe that you get a list every night. There's no need to send individual emails for the objects. But how do you find how do you connect to amateur observers? And here's where AVSO comes from. So my day job is at an Max Planck Institute, but my function in AVSO that I'm observer section co-lead. So the name is American Association of Variable Star Observers, but you shouldn't take this American too literally. Even when it was established in 1911, it was always an international organization. But yeah, amateur observers, amateur astronomers, like I guess maybe all astronomers are a bit stubborn, and they just won't rename it. Let's see what happens. So this is our mission statement. This is our from our webpage, from our homepage. So we manage our own variable star index, trying to catalog all the variable stars that we know. We even have our own little journal which is, I mean, serious. It's a serious journal in the sense that it has a peer review process, and so it's not like a place where crackpots can go and dump their stuff. It's not a really high impact thing, but it gives our members and others a way to publish in a decent way. Lots of tools for observers, light curve generators, tools to create light curves, and we also offer education videos and online courses and discussion forum where you can also interact with members. And if you don't, here are a few statistics. In this fiscal year, there were 4 million observations submitted to our database from almost 1,000 observers. Most of them, one third from the US. There are small countries that have a great, bigger community like Belgium, for example, but unfortunately just 5 from China. We need to improve on that. So we also published like 35 alert notices, and that's something like this. You don't need to set up your own big project with your own server, whatever. If you just want to get a few data points from the amateur. So this is a typical thing that was supposed to happen on Monday, I guess, where someone asked for observations from this star together with observations with Chandra. So for things like this, the observers just reduce their own data. They just typically don't send you images. They perform the photometry on their own, and they just then upload the data. I'll skip over this. This is more or less the same. You can also ask for long-term tracking of an interesting object. So this is a typical thing that this is, for example, for an AGN, which was, so every tick here is a year, actually. So there must have been 1, 2, 3 observers who just kind of adopted this object and followed it. This is just a small segment for years and years and years, because we know that sometimes it does like this flare, and then some observer said, "Oh, look, this thing is doing something, and let's observe it a bit more in detail." And since then, the observers have just carried on. The different color codes are different filters, so you can, if you don't by default, they will amateurs will most likely observe in Johnson V, because that's our favorite filter for several reasons. But you can also ask them to observe in infrared, red, blue, and this whole light curve was built with observations from several dozen observers, and you can see that they are pretty consistent. I mean, it's not like they are all over the place, more than what the source intrinsically does in variation. But it's not perfect. I mean, you see some mistakes here, like this is supposed to mean that the source is fainter than this in blue, but that's obviously not true, because there are other measurements in blue up here. But since you have many observers, typically, you can quickly find out the stuff that isn't consistent and weed that out. But you have to be careful with this. So here's a little group photo. So who are these amateur astronomers? This is from AAVSO meetings. They're older than the average, and I can see that this is an intrinsic thing. Because, I mean, if you're retired, it's so much easier to move to the countryside and build your own observatory and observe all night. If your observatory isn't robotic. if you don't have to care about your day job and getting up in the morning to bring the kids to school or go to school yourself, whatever. What there's no good reason for is that it's predominantly male, right? And predominantly pinkish skin color. So yeah, we have a diversity problem, and if we can help to mediate that by working with professionals who will show young people that not every astronomer is an old pink skin guy with white hair, that would really help us. So where to go from here? Yeah, let's go quickly through this. Maybe discuss some of the more concrete things. GCN will move to Kafka-based system, and I guess that's something you will work on anyway. I think what works now quite well is sending alerts to observers. But what with the back channel? How do you, if someone has found something, how do you get this known to the community without following too many hot pixels? So some kind of vetting, maybe. The background subtraction, if somebody could package this up so that it's easier to use, that would be great. And I guess, yeah, then maybe we have time for one or two questions. Thank you.
Thanks a lot. Questions? Comments?
Yeah, thanks for the nice talk. You mentioned the diversity problem, and I assume that it also has to do something with that it may be expensive to have your own telescope, and only a small percentage of people can afford that. Are there some approaches to, I don't know, have a network of telescopes that people can use cheaper to also participate?
Yeah, the AAVSO has actually a small network of telescopes that people can use. I mean, with the process like you make a proposal and then it gets accepted. But that is a possibility. It's a bit underused because people don't really have the guts to make this proposal a lot. But that's okay. There are things you can rent a telescope like iTelescope. It's a bit expensive, but now they have a plan that in nights with a full moon you can use their telescopes for free, or many of them. So yeah, but yeah, still it's I mean there are a lot of public observatories that should engage with people who are unable to have their own telescopes, and yeah, we certainly would support them in that endeavor.
I mean, I myself have plenty of a bit later on, but one of the crucial things I think is the feedback from the amateur community to the professional community. And you mentioned that most of the amateurs reduce their data themselves and then send back the calibrated light curve. I mean, the question is that sustainable, or wouldn't it be better to have a central, professionally run place which is able to ingest this variety of data and have the same tools basically applied, the same methods applied to all the amateur data?
AVSO, actually, this is one of the few services that is just accessible to paying members. All the others, light curves, etc., that's accessible for everyone. But we have a web-based tool where you can upload images and interactively then mark your comparison stars or get automatic recommendations for comparison. So that's pretty automatic. We offer that. I think for the more ambitious amateurs. The problem is more that they want to do the reduction themselves because they have done that. They have their own. They have built their own pipelines. They have their favorite software, and yeah, that's also something that is fun for them to do, and they keep perfecting that. And so just taking images, calibrating them, and then sending that off to I guess for many that would not be so much fun than doing it themselves. Thank you.